So this question, we have a graph. So let's start off with labeling our Oi Zerga. We have our Oi Zerga. The origin is 0, 0, so we're good there. The y-axis is the length, and x-axis is W. Whatever that is, we might think it's work. The intercept is, at W0, L equals some positive number right there. And so we could call that L0. That is the L at W when W is 0. We can read W and L. The gradient is delta L over delta W. And since we don't know exactly what those quantities are, we can't say yet. The area is L times W. So now it becomes clear to us that we need to read what this question is. The graph shows the variation with load of the length of a spring. For a load W, the length of the spring is L. So let's draw this out here. We have the length of the spring, like this. And then when we put a load on it, it stretches. So we have L. And we could even call this L if we want. And then what we have, when the load is plated on it, a delta L. So this is Hooke's law, which is F equals Kx, where X is the change in length. So on our graph, we have L, 0, and L, and this represents delta L, the change in length. So that means the gradient is the change in length, or delta X, over the load, the weight, which is the force. Now when we take F equals Kx and rearrange it, we have K equals F over X. And if we look at the gradient is the opposite of that. So it's the opposite of the spring constant, K. And so then the area will represent the work or potential energy, the elastic potential energy of the spring. So we've done our work, no pun intended, on this with Oi Zerga on this graph. And so now we want to know which of the areas represents the energy stored in the spring, so the potential energy of the spring. So which is the area that matters, that we care about? Well, let's look at each of them in turn and see what each is. So if we look at this X, that represents the load multiplied by this length up to L0. It's an insignificant, it's not important, that length. That length there, it doesn't represent anything significant. It represents L except the L0. Well, there's no work done in getting to L0, so the area of X is not important. So let me repeat that. There is no load necessary. When the load is 0, there's no work done on the spring. So the area in here is meaningless. It has no value. So let's now take a look at area Y. Area Y represents delta L times the force or the weight. So the delta L equals the work. And let's then look at choice Z. Well, choice Z is also delta L times the work. So that also seems to represent, times the weight, excuse me. So that also seems to represent the work. So both Z and Y seem to represent the work. Now let's imagine this graph. It seems a little bit odd that would be the case. Let's imagine that the length of the spring is only stretched to there. That means that the curve would look like this under that weight. And so we would have this height times this 1/2, or times 1/2, it's 1/2 the area of that W times delta L. And this Y would be 1/2 the area of W times that L. So what I'm trying to get at here is that no matter where this point ends up over here, let me change that color to red. No matter where you slide this point up here, the areas will be equal. Z will always equal Y. But the area we're actually looking for is the area under the curve between the W and the L. But in any case, either one will give it to us. So let's see. Looking at the choices, X, we said, is meaningless. B, Y minus X. Well, let's consider what Y minus X really is. If we take the area of Y, which is represented here like so, and we take the area X and draw it over top, we can see it covers over that kind of area. So we would need to come over here like this until we had this area here being equal to that. So the area X minus Y, or Y minus X, is really this, which has no special or specific meaning. So that allows us to really reason out and see why Y minus X is not a significant area that we would consider. We now go on to area Z, and that looks like that's the answer. We think that's the answer. And now if we look at X plus Y, well, since we know X is meaningless, X plus Y can't possibly be our answer as well. So this is why we have choice Z as our answer.